Minasan, konnichiwa, Zamurai Engineer desu. So in this video, let us again talk about Arduino and how to get started. So before that, I would like somebody to confirm that the sound is clear. Please confirm. Can somebody tell us if the sound is clear enough? Okay, so let us proceed. Thank you for confirmation. Shout out to you. So therefore, we need to divide this today's live stream discussion of Arduino into 4 parts. So number 1, what is Arduino? Number 2, the Arduino software. Number 3, how to get started, and hands-on. So mainly it is how to get started. Okay, so let's have this document prepared by the following: Yarilis D. Acevedo, Ariana S. Colon, Tiara, and Aviles. So we would like to use this document paid by those persons. Okay, so let's proceed to the first subtopic. What is a microcontroller? So microcontroller is a small computer on a single metal oxide semiconductor. It is an integrated circuit chip, so IC chip. Okay, so in short, MxE or MCU for microcontroller unit. Okay. So as you can see on your screen, you have the example of a Siemens microcontroller. Okay, and the microcontroller contains one or more CPUs. Okay, meaning there are one or more processor cores inside, along with memory and programmable I/O peripherals. So in one unit. So that is the difference between a microprocessor and microcontroller. programmable I/O peripherals. Okay, so let's go on further. Okay, so let us say we have a desktop and a laptop. So we can compare laptop or desktop versus the microcontrollers. Microcontroller can be viewed as a small scale representation of laptop or desktop. Okay? Actually, laptop and desktop, they are called microcomputer. They are called microcomputer. Desktop is a microcomputer. Okay? But although they are called microcomputer, a very, very small version of that is microcontroller. Okay? As you can see on your screen, we have an example on the left, the desktop computer, and we have the specification on your right, the microcontroller, which is being used in our Arduino Uno. Okay? So CPU speed for desktop currently, that is about 2 to 3 gigahertz currently, quad core, meaning there are 4 microprocessors inside the processing unit IC of the laptop or desktop. Okay, so while in the Arduino, it is using a CPU with a speed of about 16 megahertz. Okay, so it is not a quad core. There are 1 or 2. Okay, it's not a quad core. And the actual IC is called at 80 mega 328 80 mega 328p. Okay, while your example on the left is the Dell Precision Desktop T1500. Okay, that is the actually the motherboard. Okay, T1500. So with that motherboard, we have the RAM about 16 gigabytes. Imagine 16 gigabytes RAM. While the RAM of Arduino is 2 KB. So KB. Okay. Multiplied by 8 million. So 2 KB multiplied by 8 million. That is 16 gigabytes. Okay. So imagine the difference. Okay. Imagine, you can just imagine the difference. RAM. Okay. So RAM is 16 gigabytes. 16 giga meaning billion. 16 billion. You are comparing to 2,000. 2K is 1,000. So multiply by 8 million. So 8 million times. That's why I am saying very, 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 very small version of a computer. Okay. Storage for a desktop computer, 2 terabytes, 1 terabyte. Even the laptop, even a laptop normal is 1 terabyte. Normal for a laptop, 1 terabyte. But for our Arduino storage, 32 KB. Okay, 32 KB program memory. Okay, 32 KB. Terabyte is trillion bytes versus 32,000. Okay, so about what? About 16, about 100 about 160 billion times. Oh. Okay. So it's too much for comparison. It's too much. Okay. I/O for a desktop computer, USB, firewall. Imagine there are several USB that could be used by a desktop computer. Even laptop computer, at least we have 3 USB port at least. Then you have firewall, serial, PS2, RJ45 jack, and audio, etc. Okay, for what? It's DMI port. You have its DMI port. Okay, there are so many IOs. Okay, but for the Arduino, we only have up to 23 generic IO, 6 of them analog, UART, SPI, and the like. Wow. Here with us is Anak Magsasaka. Shout out to you, Anak Magsasaka TV. Okay. So that is the comparison between the computer and the microcontroller Arduino. Imagine. So what is therefore the purpose of Arduino? How can I use it and implement it in the lab or in our project? Okay. So Arduino microcontroller is a project that began in 2005 alone. Only in 2005 as a tool for students at Interaction Design Institute in EYPEI. So EYPEI is a city in Italy. Okay, so it aims to provide low-cost and easy way for novice and professionals to create devices that interact with their environment using sensors and actuators. That is the method. Initially, previous to that, much earlier, good evening sir, patambay saglit at hindi pa inabot ng anto. Mega love shoutout sa thank you Anak Magsasaka. Okay. So in Italy before 2005 and around the world, even in our country, we are using PIC microcontroller, PIC microcontroller before that. Okay. So and after the introduction of Arduino, suddenly there are no PIC in our country. You cannot. It's very hard to buy PIC right now. But year 2000, there are several electronic shops that offer or sell PIC microcontroller, and they are being sold at very high price. They are very expensive. Okay, that's why only those rich students and well-to-do family would be able to provide training, a very good training for their sons and daughters. Okay? But currently, the value when you buy a piece of Arduino microcontroller right now is very inexpensive. It is not expensive anymore. Particularly Arduino microcontroller is a open source hardware and software. So anybody can make their own Arduino board, and that's why it is very cheap, because there are a lot of companies nowadays that produce Arduino, not the original one. They are called clone. similar to our desktop computer. Similar to desktop computer. Desktop computers are originally IBM. And currently, you cannot see IBM computer. You can only see IBM computer in big companies. They are buying the branded type of companies. Right now, the analogy is IBM computer is just like an expensive car. For example, BMW. For example, Mercedes-Benz. For example, Mustang. Okay? For example, Porsche. Okay? So those are the brands. Those are the branded the ones. Okay? But we have the generic cars on the market like Toyota. Okay? Majority of the products of Toyota are generic. Okay? So there are a very small percentage of Toyota model cars that is considered as expensive. Okay? Mostly the low cost Toyota cars. Okay? So those are the same thing with desktop computer. Your desktop computer in schools, they are mostly generic. They are mostly clone. They are what we call clone. So the same is true with Arduino. Right now, there are clone Arduino microcontroller. That's why the price is very low. You can buy Arduino microcontroller less than 1,000 pesos. Okay? Okay? There are less than 1,000, sometimes 500 pesos. Okay? So it's not very so. What I'm saying is year 2000 to year 2000 to 2004, the price of a microcontroller is about 20,000. The cheapest 15,000. That is the cheapest. 10,000 probably if second hand. Okay? You cannot buy. Anybody cannot buy that. Those well-to-do families are the ones who can buy and provide for their daughters and sons. Okay, but the majority of the country's students cannot do that. Okay, so that's the definite quality jump. Arduino is better in quality and also low cost. Okay. So Arduino microcontroller is an open source, just like what I've said. Okay, that's why everybody can clone. Clone is not a fake, just like our computer. Generic computer is a clone, but it is not a fake. Okay, that is not a fake. A fake is different from clone. Okay, okay. So clone of IBM computer. That is clone of IBM computer. Even the laptop, they are clone. Okay. There are several brands in laptop and desktop, but for example, Dell computer is a brand, but mostly IBM. For example, in laptop, the best brand probably is, for example, Apple. Right? Apple is the brand. You cannot see a generic Apple. So if you see an Apple which is not original, that is fake. But if you see a laptop without brand, that is not fake. That is a clone. Clone is legal. That is the difference between clone and fake. Okay? Fake is illegal. Okay? So take note that cloning is legal because they come from open source platform, just like what is being explained right here. Okay? So they are able to read inputs, light on a sensor, a finger or a button, or Twitter message. Okay? So this Arduino Uno can be used to tweet a message and turn it into an output, activating a motor, okay? Turning on an LED, publishing something online. So it can be used as IoT. IoT is what we mean by IoT is Internet of Things. That's what we mean by Internet of Things. Okay? Okay, triggering something uh, to operate online. Okay? Okay, anak mo ka, sir, good night na. Naglo-loading na net ko. Okay, thank you. Thank you. Shout out again to you. Anak mo ka. So, activating any mechanical or motor or device online using internet is what we call IoT, Internet of Things. So what it is used for? Physical computing projects, search, can be used interactive installation, can be used rapid prototyping. So as you can see in your screen, this is the size of the Arduino Uno. This is the small size. No? Actually, this is not the smallest. We have the Arduino Nano. Arduino Nano is the smallest version of microcontroller, Arduino Nano. It is similar to Arduino Uno, but there is no USB port. There is no power jack. Okay? There is no power jack and USB port. That's why it is very small. It's smaller than Arduino Uno. That is Arduino Nano. Okay? So, again, what can I do with this? So we can use sensor, we can use actuators. Okay, so sensors and actuators. Sensors are the inputs, possible inputs of the Arduino. Actuators are the possible outputs of the Arduino. Okay, sensors are those push buttons, touch pads, tilt switches. It could be variable resistors, sliders, or volume knobs. So volume knobs, those that could control a volume in analog manner. Okay? So photoresistors could be used, thermistors, ultrasound, and so on. Okay? What are the example of actuators? Could control light, Arduinos could control LEDs, motors, speakers, displays, okay? And so on. So there are so many things that we can do about it. So there are several types of Arduino, just like what I'm talking about. So Arduino Uno is the basic form. This is the basic form of microcontroller. We have Arduino Leonardo. We have Arduino 101. We have LilyPad. Okay, so there are several ports, USB. We have Arduino Robot. Okay. We have Arduino Explora. So Arduino Micro is smaller than Arduino Uno. It is almost the same as the Arduino Nano. So this is the Arduino Nano. Okay, Arduino Micro. So Arduino Mini is a little bit bigger than Arduino Micro. Arduino Mega. Okay. So Arduino Yun. So this is the current popular nowadays. Arduino Yun and Arduino Zero. Okay. So this is the current popular nowadays. Okay. This two and also this Nano. Okay. What is the difference between these different types? Okay. So types of Arduino, they differ from this specification. Okay. So particularly we need several I/O. We need several analog I/O. So digital I/O, analog I/O. Let's compare. Okay. So basic form Arduino Uno. Okay. 14 digital I/O. Arduino Ju 54. Take a look how many digital I/O increased from Uno to Ju. Mega 54. Leonardo 20. So an increase in number of digital I/O. Also in analog I/O, only 6 input, 0 output. Analog I/O, 12 input, 2 output for Ju. How about for Arduino Mega, 16 input, 0 output, and then Arduino Leonardo, 12. So this is the basic form. This is the basic form, Arduino Uno. Very limited amount of I/O. So this is the board. You can expand. We zoom. Okay. Let's zoom in the board. So in actual, the board only looks like this. This is the actual. So actually we zoom 5 times, no? 5 times. This is 5 times its size. This is 5 times. So there are 5 Arduino Uno here. So 1, 2, 3, 4, and then 5. Okay. So power supply you can directly put here, but again, if you put the power here, for example, the power in here, voltage in and ground, okay, do not ever make a mistake, because this board will be damaged instantly if you make a mistake. Okay, so it's better to use USB port as a power supply, or the power jack as the power supply. Better to use this is power supply rather than this one, because there is a protection for this, but there is no protection for this. It will easily get burned down, okay, and be damaged. Okay? So this is the ATmega 16. This is the ATmega 16 U2. But okay, this is R3. This is the revision 3. Because in revision 1, the reset button is here. The reset button is in the corner. So since the reset button is in the corner, this is revision 3 of the Arduino. Okay. So konnichiwa, sir, for Ding Tumangao. So shout out to you, Mark Dizon. So this is the 80 mega microcontroller. So this is the digital output, digital I/O, 01 serial port, okay, and this is the USB port, power jack, analog. This set, there are 6 analog I/O or input only. We cannot program it to become output, but the I/O, the digital I/O can be programmed to be either input or output. You can program it using the software. Okay. Okay. So made in Italy. So this is the original Arduino manufacturer, made in Italy. Okay. Okay. But currently there are several. So this is the serial port for circuit serial programming. Okay. Anyway, so we have the analog and digital pins. Okay. Arduino can input and output analog signals as well. So there are 6 of analog signal, input signal. Okay. And there are about 23 digital I/Os. Okay. So how Arduino is programmed? So this is our part 2 using IDE. So what we call Arduino IDE. You can actually download it and install it into your desktop or laptop computer, downloadable for free. Okay, so you can do it. And let us discuss something about that. Arduino software, how Arduinos are programmed. So IDE meaning Integrated Development Environment, or IDE. So just search for it, then you will find several sites that would have the available download of the software. That is open source again. That is open source. So what is the programming language? So there are several possibilities like simplified C or C++. We call the program sketch. Okay, we call it the sketch. So sketch it in C, sketch it in C++. Okay. Based on the wiring project, wiring order, so we can use wiring. So without the use of computer, desktop, or laptop, it is also possible. But I did that on our time, year 2000 and older, but it is very hard to do because at those times we are using assembly language. I programmed the microcontroller in assembly language, okay? Line by line. Okay? So and born it again using small adapter equipment called ROM burner. Then it's very hard. It's very hard. You need extra energy, effort, and extra allowance for time. Okay, for testing those things that are not really involved in the actual program. So preparation, it is important and needed, but not needed on the actual program. That's why it's very hard. Right now, you can do it based on wiring. It's better that you have to experience this wiring programming through this wiring, so series of on and off, okay, or assembly language. But after you experience it, better to transfer already to C language or C++. Okay. So peripheral libraries are available currently. There are so many available functions that you can just use for free. Okay, LCD sensor, 12C, etc. Different types of control functions. Okay. So, for example, these are the very common control functions. Pin mode. So you can define a particular pin as either input or out. So digital write function, you can set the digital pin high and or low. Okay, you can initialize a pin. Okay. Digital read, you can read the digital pin state, what it is currently doing. Okay. And analog read, you can read the analog pin. And you can write an analog PWM value. Okay. Delay, you can wait an amount of time, specific amount of time. Okay. So it is very important, okay, to have this as a fundamental function in your system. Okay. Millis, get the current time. So these are very basic necessities for programming the Arduino. So how the program looks like. This is what the IDE look like. This is the Arduino IDE. So if you open it, this is the first thing that you can see in the Arduino IDE. So interactive development environment. So already you have to set up function and loop function. These are the two main functions. So setup meaning you have to put your setup code here. It is only run once. Then here put your main code here to run repeatedly. It would be called and recalled by the bootloader, okay, continuously. Okay. So what are the different types of parts of these global variables? Declare variables at the top. Then the name. Okay, initialize setup, run once at the beginning of pins, then loop repeatedly. So this is the format of a complete program for Arduino Uno. Okay, so you can declare the variables before the setup. Okay, just to introduce the variables to the system. So let's see how a sketch for turning an LED light runs in an Arduino. When we say sketch, we mean when we say sketch, we mean the programming commands. Okay? The commands. Okay? That is what we call sketch. That is look like this. At the background, in the background, you are looking at the real program for Arduino, and that is called sketch. It's called sketch. Okay. So, for example, this is an actual example: blinking light. So, power on, reset, then pin 3 blinks fast. So, pin 3 is the internal LED of the Arduino. So wait 5 seconds for upload, then execute existing sketch. Okay, upload new sketch if you want. So this is here. Okay, looping. So okay, so integer. So int lead pin, okay, is equal to 13. So we introduce the variable. Okay, void setup. So we initialize. So how to initialize? So we only use pin mode function. This is to define the pin. So lead pin, meaning we define pin number 13 to be our output. Okay, so that is what we mean by this. Okay, so that is our output, pin number. Then after initialization, so this is initialization, loop function, loop. Digital write. So we use the writing of the LED. What LED? The LED that is connected to the pin number 13. So lead pin connected to the number 13. Okay, so let us turn it on because it is high. Okay, and then turn it on up to 5,000. So 5,000 meaning 5 seconds. So 1,000 is 1 second. Okay, so 5,000 5 seconds. So just choose the function. Okay, so meaning to say there are already persons that already made this function. Actually, you can make a delay function if you want, but it is already in the library, so we can just use it. So if you know C language, that is how it works. If this is not available, you have to do it by yourself. If this is available, it's better because we can easily use it. Okay, digital write, lead pin. So let us write on that lead pin what number? 13. So let us write to the lead pin number 13 low, meaning we turn it off. Okay, we turn it off for how much? 5 seconds. So meaning this program will alternate turning on and off the LED every 5 seconds. Okay, so that is how it will work, this program. Okay, so very simple program. Okay, Very simple program. Then after that, you have to compile it. So after compiling, it will give you this message. Okay, it will give you this message. The sketch uses 936 bytes. So that is your amount. This amount of program is equal to 936 bytes. Okay, so that is how you make the program. So global variables, for example, we use this part. So LED connected to the control pin 30. That is what we mean by this. Okay, that variable. Then setup, that is the initialization. We initialize the pin definition. Okay, we define the pin to be our output. Okay, so loop, digital write, delay, digital write, delay. So digital write is the only, digital write and delay are the only function that we use here. Okay, while this one we use the pin mode function. So there are only three functions that we use in this program, and all of those three are already on the library. We are not doing anything. We are just putting it on the format. So that's how easy it is to program a microcontroller today. So in our time, that is the case. Okay, so we have in our IDE, Arduino IDE, the integrated development environment, we have the verify button, upload button, new sketch, meaning you want to write a new program, open, then save, then search. Okay, so those are the button of the IDE. So how to get started? So this is the third topic. So if you have the board, then let us use it. Arduino board. You have the USB cable, then power supply. So let's connect it. Then download the Arduino software. Okay, just like what I've told you, you can download it for free, then install it. Then plug it into your computer or laptop. So if you install the Arduino IDE software in the laptop, you have to plug in your Arduino board into your laptop so that you can okay, like this. Okay, so write in downloading code, write sketch on PC. So this is the Arduino. So connect the Arduino via USB to your PC. So download sketch to Arduino. Sketch meaning the program, meaning download the program to Arduino. Okay, so this is our point of view. We are inside A, that's why we are downloading it from the laptop. Okay, so because we are talking about Arduino, so we are downloading the program from the laptop to Arduino. Okay, so download. Okay, so if you are online, you can also go to Tinkercad. It's a free online 3D modeling program that runs in a web browser known for its simplicity and ease of use. Tinkercad. So it is again a product of Autodesk, just like AutoCAD. Okay, and since it became available in 2011, it has become a popular platform for creating models for 3D printing, as well as an entry-level introduction to constructive solid geometry in schools. Okay, so Tinkercad. Okay. So that is what free online 3D modeling program. So we cannot download it, but we can use it for free if you are online. Okay, Tinkercad. So Tinkercad, make an account in Tinkercad, and it's free. So you can easily do it like this one. So go to Tinkercad. I will show you here to tinkercad.com, then dashboard, and so on. So just type in the tinkercad.com. You will go to this page, and this is the home page. So click, so make an account. This is for free, and create new circuit. Okay, click create new circuit. Then after that, this would be allowed to be used or to be open, or meaning to say it is now enabled. So you can enable this. Which one do you like to? Just select which one do you like to use. Okay. Then scroll down until you find the Arduino Uno. So you have to select up to the Arduino Uno. So then after you find out the Arduino Uno, then choose it. Find the resistor and LED. Okay, that could be connected as our output. Connect the resistor to the ground. Okay, that is the proper way to do it. Then connect the LED or the shorter leg. Okay, the shorter leg, this is the shorter leg, with the resistor, and the longer leg to pin 12. So pin number 12. So we will use pin number 12 in our program. So remember that. You have to remember where you put your output light. So because we want to control pin number 12. Okay. So write the code. So write it here. Okay. Then start simulation. After writing the code, you can push this button to simulate. Okay. So in this manner, we can what? We can use the Tinkercad in this way. So you have to write the code again, like the one we already done with. Okay. So pin number 13. Okay. So 13 here, but since then we are using pin 12. Okay, so this is what we are going to do. Button. Okay, so button program, constant on change. So meaning to say, let us make it as global variable, constant integer button pin is called number 2. Pin number 2 is the button pin. Pin number 13 is the LED pin. A variable will change. So integer. So this is how we use variable. Button state is equal to 0. We initialize the variable. The initial value of the variable is 0. This is constant, will not change because we have the word const. Okay, so we declare that as constant. So we declare this variable. We only say integer. Okay, so void setup, initializing, void loop. So that is our first program for void setup. Look, initialize the LED pin as output. Pin mode, output. Okay, LED pin is 13. So that is our output. Initialize push button pin as input. So pin button pin, that is number 2. So we just define that we introduce. Okay, then loop. Okay, so read the state of the push button value. Okay, check if the push button is pressed. If it is the button state is high. Okay, see if the button state is equal to high, then turn the LED on. So this is just a very simple application of controlling a light by a button. So one button, one light. Okay, very simple. But through the use of microcontroller. That is not necessary, but just to start, okay? As it is not necessary to control one LED by microcontroller, but just to start studying the microcontroller itself, how it will do its job, okay? How do we create the program? So we will create complicated, more complex program later on, and that is the same concept. Okay, for example, moving a stepper motor. Now, stepper motor, we can move a servo motor, we can move a stepper motor, we can move any type of motor. But a small stepper motor, if it can be directly attached to the output of the controller, it's better. As a second example of our project. Okay, so connect. So this is the stepper motor. Okay, so using a potentiometer. So we will use the potentiometer to do that. Potentiometer is a variable resistor. Okay, so using a load cell. Okay, so this is the stepper motor. This is the moving part, this yellow part connected to the motor cell. So this is the motor cover. This is the motor cover. So inside this is the wiring of the motor. Okay, so stepper motor. Stepper motor looks like this in reality. So these are the wiring for the stepper motor. Usually 4 wires and 4 or more. Okay. So you can do it, connect it using a potentiometer to be able to to have a voltage divider for that. Okay. So load cell, using load cell. So load cell is a input, because it is a sensor. Okay, it's a sensor. So more projects can be used. So we will show you these things when we have the actual Arduino. We'll show you how to do it, do the connection, the wiring, and do the program. Okay. So more projects, we will upload more projects and more sample and show you and demonstrate those projects. Any questions? So any questions? We will do the hands-on in our last part of this course. Okay. So instead, when you are my student of mechatronics, you are now preparing for the projects, and I hope this discussion would help you somehow to realize something about this, because you are mechanical engineering student, you may not have the proper background introduction to electronics and computer devices like Arduino. Okay. If you have any question, you can do it right now, and there are no questions. We have a challenge project. Okay, challenge project. You can control LED using a button. So this is the one that we discussed. The programming. This is how you have to connect it. So you have to connect the output ground. This is the ground. So this is the pin number 12. So we use pin number 12. So the program is in error. We use pin number 13 in the program. So pin number 13 is actually internal LED. So there is internal LED here. So I think this is the internal LED. It will blink. But if you use the this is input. So input is, this is the push button input. Okay, going to the, I think, pin number 2. Number 2. Pin number 2 is the input, and then pin number 12 is the output. Okay. So I don't think this is LED. It looks like LED. This looks like LED, but it also looks like a capacitor to me. It looks like a capacitor. So this is the output LED because it is connected to number 12. So the program is so this is the next one, the next problem. So they using the potentiometer, brightness control of the light, and this is the scrolling of LED. So this challenge problem, I will show you again. This is the program for the challenge problem. Button number 2, output number 13. Okay, but here in the actual it is number 12. Okay, pin number 12. So be careful about that. So in reality it is connected to number 12 here. You can see it. So pin number 12, which you can see it. This is pin number 12. Be careful. Okay. So anyway, that's all with our discussion of how to get started with Arduino. Okay, so I will wait for about 10 to 15 seconds for your question. If you have any, I would be glad to answer them. You have to put your question on the comment or the chat box below. So anyway, there are no questions. So see you in the next live stream and lecture video. Thank you for patronizing our tutorial channel. This is Dr. AP, Teaching Engineering for Nation.